Well, hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. So you have a problem known as Stickler Thief. This problem, Stickler Thief 2, exactly. So the Stickler Thief 1 problem is very much simple with this, similar to this, and it says that we are a thief and we are given an array ARR where we have houses arranged in a circle. So remember in the previous problem it was not a circle, it was just a straight line, and now we have a circle, and as previous we need to maximize our loot, and the only problem here is we cannot loot the adjacent houses, and as it is a circle the first and last houses are considered adjacent. So here you can see we can take 2 and 2. It can be 4, but hence it's a circle, we cannot use that, so either we are taking 3 here. And similar goes in this way, that we are taking 1 and we are taking 3, so that comes over 4. Similar to this we take within the last example, as we take this 2, we cannot take the next 2, we need to take 3, which boils down our total to 5, and we also cannot take this 2 because this 2 and this 2 are adjacent, considering this everything is in a circle. So the houses are like 2 2 3 1 2, and then again 2 2 3 1 2, and again 2 2, and so on. So if you are very much familiar with my earlier code, and I would highly insist to go ahead and check the previous solution where we have coded it in such a way. So we have a recursive method and we introduce a cache and an integer I, right? So I is nothing but it denotes the problem where to start, or the index where to start from, looking within the A houses, and this is just a cache element. Notice I have added a new element over R, where to stop and where not to. Why this R has been added? This R has been added to understand where to stop. You see, the only thing which is stopping us to go ahead and calculate this is if I'm choosing one, if I'm choosing the first element, I should not choose the last one. So how to make a decision about it? Well, it's quite hard. I would admit it. Let me write down what the problem is. How to choose or not to choose the last one, or how to understand to take or not take the last. And I completely relate to you that there is no way. So again, so sorry. So I completely understand with you that it's quite hard, and it might not seem that there's a way to find out whether to take or not take the last element. So what I say is, so leave it, don't care about it. So what I'm saying is, if you're going to take or consider last element, so ignore the first element. This is first thought process. We can also say, if you are taking the first element, do not even bother to consider. I'll just take it in the line, then consider the last. These two things, and just these two things solves the problem. What do I mean? So if you're taking the first element, so if I'm considering houses or an array, so I'll say the array consists of 0 to n minus 1. Let's take it over here, n houses. How are n houses? 0 to n minus 1, right? And but now I'm saying 0 to n minus 1, do not consider it. Consider if you're taking the last element, ignore the first element. So what is the last element? N minus 1. Ignore the first element, means consider form 1. Go from 1 to n minus 1. And this would be very much clear, pretty much clear once I draw down the picture below. So, and we are also saying that if you're taking the first element, then the first element is 0. Do not even bother to consider the last element. So n minus 1 was the last element, n minus 2 is the second last element. Well, nice. How would this solve the problem? This would solve the problem because we are boiling our window down. So we are sure that if any of the element is in between, we are guaranteed to capture it. But we are not sure of the edges. So for the edges, take this window first and take that window second. That means we are going to execute this recursive methods not once but 2 times. So return math.max. It's a pretty small line of code. I'm going to write over here recursive a cache. Let me introduce a new cache over here. New int. Let me take down a dot length, and from 0, what I mentioned is 0 to n minus 2, right? What is n? So I'll say final int n is equal to a dot length. Let me remove this n. So n minus 2. And next, what I said, to 0 to n minus, okay, it was 0 to n minus 2, and I said 1 to n minus 1, right? So I'll say recursive a to new int of n, and I'm taking 1 to n minus 1. Cool. What is this minus 2 minus 1? Yeah, this is the last limit where you have to check whether if I'm exceeding this last limit, then don't even bother to go ahead. And that's all. That's all we need for now. And yeah, cache is the same, and we either to take this or not take this is the same. Considering taking would skip the next immediate house, and not taking would go in the linear manner one by one. So let's try to run this program and check whether it compiles well or not. Well, it works with the sample test cases. Let's test it for the rest of the test cases and we would be good to go. This problem, instead of recursive, can be solved with the iterative method, and I have mentioned all the 3 methods, knife, recursive and iterative, in my previous video. You'll find the video on the tile right, and I'll see you in the next one.